So learners, you have reached the chapter number 3 of the course of Basics of Economics. And in this course, we are going to talk about partition values. Now, what is this partition values? First thing, we are going to understand the concept. We are going to understand the formulas. We are going to take up a few examples of how partition values are calculated, computed, and used in economics. Let's see some things which you have learned in standard 10th. Now you'll say, why 10th now? Yes, we need that because that will form our basis of computation of these partition values. So first of all, you have learned arithmetic mean. If you remember these formulas of individual data, how you compute the mean, discrete data, how you compute the mean, and if it's a continuous data, how do you compute the mean? Then we also have mode and median. So these three terms, arithmetic mean, mode, and median, is something which we are going to use. These formulas we are going to use for the purpose of computation of these partition values. Now let's first understand what is this partitioning mean, right? If we have to divide the data, we have to divide the data into equal parts. And this particular division is called as partitioning. Now the values that we are going to divide, these values will be called as the partition values. Measures of central tendencies, what they are called as in arithmetics, it is called as central tendencies. And these are what basically the mean, median, mode. These three valuations we are going to consider. Now, when we say median, median is an important factor which says this is the middle, this is the center, this is the division of those entire values into two parts. So it's the middlemost value of that particular entire data set. And when it is the center value, when we are arranging the data either in ascending order or in descending order. Then we have what we call as quartiles, deciles, and percentiles, which are also a part of partition values. So partition values are also called as fractiles. Fractiles is the word, if you say fract, it means fraction. So we are dividing. So fraction, that's why it's called as fractile. So it's easier to remember. Now, why we need these values is a very important thing. Suppose I say what is the average population of a particular area in the last 10 years? Or birth rate in a particular region in the last 10 years. Or if I ask you what is the national income of India and what is the average national income of India in the last 50 years or whatever. So the data which we are using, directly using an average, directly using a simple average will not give you the results. So that's why we need a little bit more mathematics to get involved in economics, and that's why we're using the partition values. Now, just for some general knowledge, there is what we call as a World Statistics Day. And Professor Prasanta Chandra Mahalanobis and Professor Prasanta Chandra, an Indian statistician, was instrumental in formulating India's strategy for industrialization in the second five-year plan in 1956 to 61, and later on this was called as the Mahalanobis model. Okay, so what is this? This is basically 5-year plan. Every 5 years the country designs like a budget, like a plan for what it's going to do in the next 5 years, like infrastructure development, any achievement oriented thing that it has to do and accomplish in the next 5 years. So that is what we call as the 5-year plan. And this particular Professor Prasanta Chandra Mahalanobis is the one who formulated what we call as an industrialization strategy for industrialization in this particular 5-year plan. He devised a comparative model that is called as the Mahalanobis distance. Okay, so 29 June, which is his birth anniversary, is celebrated as Statistics Day in India, 29th of June. So basically, this is what we call as a comparative model, and this is a very important model used in economic analysis. Now, why we need partition values, right? As I told you in the beginning, to get some data analysis knowledge, which we need to understand. But at the same time, if you see a simple example, if we say that there are extreme values also, like the data may not be uniform, there could be extreme values. and that's why it could be a very low value or a very high value in between. And if you just take the average, it's going to give you a misleading result, and you cannot just say, okay, this is the average of the last 10 years. That means this is the average of the data. So if I say average birth rate in the past maybe 10 years is 2200 whatever. So if I say 2000 is the average birth rate, but every year the figures are like small, but only in 1 year there is a sudden growth, then the average will not be correctly stated. So we'll take an example to understand this. If we take the values like for the last 10 years of sales which were made in lakhs, 4 lakhs, 5 lakhs, 5 lakhs, 4 lakhs, 80 lakhs suddenly. Then again 5 lakhs, 4 lakhs, 4 lakhs, 4 lakhs, and 5 lakhs. So this is what we have as the 10 years of data for the purpose of sales. Okay, now if I say, tell me what is the average sales in the last 10 years, what would you do? Simple average, if you take out, simple average will say, okay, 120 total of all the values divided by 10 years, and we get 12 lakhs. So if I say 12 lakhs is the sales of that particular organization, average sales in the last 10 years, will it be correct? Look at all the years. Most of the years have values of 4 lakhs and 5 lakhs. If it has 4 lakhs or 5 lakhs, and suddenly you're saying 12 lakhs is the average because of that 80 amount which has gone up, it is something which can be wrong, correct? So it will not be, it is something wrong. The average is not the one which will give us a correct picture, and hence what happens, we need the different valuations in terms of what we call as median, quartile, deciles, percentiles, and these are used in economic analysis. We will see how they are computed with the help of examples in the things in the video ahead.